Alright, now let's start on squares and rectangles. Okay, over here you see two figures again, square and a rectangle. Okay, I'm sure you know that this is a square. I'm sure you know this is a rectangle. This is what you learned in lower primary. You see this shape, you can recognize as a square. See this shape, recognize as a rectangle. But there's more to that than just by looking. There are properties of squares, properties of rectangles that we need to know so that we can differentiate them, so that we can separate them. And most of these properties or characteristics are the same. Some of the features of a square are the same as that for rectangles. Some of the features here, same as here as well. But there is one major difference that makes a square different from a rectangle, and a rectangle different from a square. And this is where we're gonna see. Okay, so let's look at the features first. Okay, you see this table here. Basically, it's a table I'm going to use to tell you the differences and the similarities between a square and rectangle. So let's start with something simple. Let's start with the similarities first. Okay, similarities means things that are the same between a square and a rectangle. Okay, so first, just by looking, how many sides do a square have? Okay, I know this is four-sided. How many sides does a rectangle have? I also know is four-sided. Okay, so the first similarity between a square and a rectangle is that they are both four-sided. Just count 1, 2, 3, 4. 1, 2, 3, 4. Both square, rectangle, four-sided. Simple. Okay, second. Okay, next is about the angles that they have inside the figure. So again, if we use a set square and check, okay, we use a set square and check, this angle here is a right angle. How about this? Right angle as well. How about this? Right angle as well. How about this? Right angles as well. We're going to do the same for all the four corners or all the four angles of the rectangle. Alright. Right angle for this. Over here. Right angle for this as well. This right angle. And the last one, we can probably predict that it's going to be right angle as well. Okay. So after doing all the checking, what do you realize? Okay, you probably realize that all the angles inside the figure are right angles. Okay, angles, remember, are the points when lines meet. Okay, it's the amount of turning between the lines. So you realize that all these angles, they are right angle. So another similarities besides being four-sided is that all angles are right angles. Okay, same thing over here as well. All are right angles. Okay, this is a very important properties to know, because this one will help you do a lot of problems later. Okay, knowing that all the angles inside a square, all the angles inside the rectangle are right angles. Okay, and lastly, look at the length. Okay, this is about the angles. Okay, I just put angles here just to make sure. The other one is about length. Okay, I want you to look at the length. Okay, look at AB and look at DC. Do you think AB and DC have the same length? Let's do a measure. Let's measure and see. Okay, this AB is 2 cm. This DC is also 2 cm. Okay, let's go on to the rectangles and measure. Let's measure EF. EF is 4 cm. HG, 4 cm as well. So what do you realize here? Just by looking, AB, CD, are they the same length? Yes. And you realize that AB and CD are opposite sides. So for squares and rectangles, the opposite sides are actually the same length. Okay, and the opposite sides are also parallel. Remember what we learned just now? That parallel lines are lines that never meet and they have equal perpendicular distance apart. So first thing about length, okay, let's just write down first that opposite, I'm going to use short form, opposite sides are equal length. Okay, this one is for both squares and rectangles, and also opposite sides are parallel. Okay, let me explain this again. I know it's a bit confusing here. Okay, let's look at the length first. Opposite sides, AB, DC, opposite sides. EF, GH, opposite sides. Opposite means opposite lah. Quite obvious lah, opposite. Okay, and you look at the length. AB, 2 cm, DC, 2 cm. Opposite sides, same length. EF, 4 cm, HG, 4 cm. Opposite side, same length. Okay, so this is what I mean. Opposite sides, equal length, same length, opposite side. Okay, how about this? Opposite sides are parallel. Remember, parallel lines, lines that never meet, lines that are equal distance apart. So you realize that opposite sides, okay, they are parallel. I can use the arrow to represent they are parallel. Okay, I can use the arrow to represent they are parallel. Okay, and let's look at another pair of opposite sides. Okay, let's look at AD and BC. Okay, I know they are right angle. The perpendicular distance are the same. They are parallel. I use a double arrow here because just now I used a single arrow already. So double arrow as well. Okay, so for squares and rectangles, the opposite sides have equal length. Here and here. Even if I want to try DC, AD is the same as well. This is 2 cm. This is 2 cm. I want to try EH and FG. This is 2 cm. And this is 2 cm as well. Okay, so this last point, opposite sides are equal length. Opposite sides equal length. Opposite sides equal length. Opposite sides equal length. Opposite sides equal length as well. Okay, and this point about opposite sides are parallel because these two lines AB, CD, they never meet and they are equal distance apart. They are parallel. Same for here. Let's look at EH and FG, these two vertical lines. They are parallel and they are equal distance apart, which makes them parallel as well. Okay, so these these four things, let's just put a alphabet to it. A, this is B, and this is C, and this is D. Okay, so just do a recap. What are the similarities of squares and rectangles? First, just by looking, you know that all of them are four-sided. Squares are four-sided, rectangles are four-sided. Very simple. Okay, second, all the angles inside the squares and rectangles are right angle. Just use a set square to check. You realize that all the angles are right angle. Okay, third one, opposite sides are equal length. AB, same as CD. EF, same as HG, same length. And then opposite sides are parallel. Okay, opposite sides parallel, opposite sides parallel, opposite sides parallel, opposite sides parallel. Okay, these are the similarities. But if they only have similarities, then what makes a square different from a rectangle? And there's only one main difference between a square and rectangle, and this is what we call the difference. Okay, so what is the main difference? Okay, does a square look like a rectangle? Does a rectangle look like a square? No, they don't. One main thing that separates a square from a rectangle is that squares, okay, for squares, all sides have the same. Fill in the blank for me. What do you think? Look at this square here. AB, BC, CD, AD. What do they have that are the same? Okay, you realize they have the same length. Or all sides have the same length. Right? But look at rectangle. Okay, let me just write rectangle over here. What about rectangle? Look at EF, FG, GH, EH. Do all the four sides have the same length? No. If they have all the same length, they are squares, because squares or sides have the same length. So for rectangle, the difference is that only opposite, I'm going to spell it out for you, only opposite sides like EF and HG have the same length. Okay, this is the main difference between a square and rectangle. Squares, all sides are equal, 2 cm, 2 cm, 2 cm, 2 cm, all the sides are equal. But for a rectangle, only opposite sides. Opposite sides meaning EF, GH, EH, FG. Only opposite sides, same length. Only opposite sides, same length. And this is a major, very important property to know, because when it comes to drawing squares, you must know that squares, all four sides are the same. Drawing rectangle, you must understand that opposite sides have the same length. So if I only give you one side, you must be able to tell me the other side. If I only give you one side, you must be able to tell me all four sides for squares. Okay, so this is the main similarities. So just do a bit of recap, a bit of summary. Similarities, squares and rectangle. First thing, as you can see, four-sided. Second, all the angles inside are right angle. Use a set square, you can see. Okay, the next one, length. Okay, you realize that opposite sides, same length. Opposite sides, same length. Same for rectangle. Opposite side, same length. Opposite side, same length. And for direction, opposite sides parallel. Opposite sides parallel. Opposite sides parallel. Opposite sides parallel as well. Okay, but the main difference between a square and a rectangle is that for a square, 2 cm, 2 cm, 2 cm, 2 cm, meaning that all sides have the same length. But for rectangle, 4, 2, 4, 2. You realize that only the opposite side have the same length. And this is the main difference between a square and a rectangle. Okay, knowing that, before we go on to the workbook and do some examples, okay, one thing to note, because I have covered squares and rectangle before angles, there are something that you might find very hard to understand, especially when it comes to this thing called right angle. I'm going to write it down here, right angle. Okay, right angle is not new to us. We know that right angles are basically, if I use a set square, and if I draw two lines, let's draw one line here, and then if we still remember how to draw a perpendicular line. Okay, let me just demonstrate. Okay, like that. Okay, I put a ruler here and draw a line over here, and then I know that this is a right angle, because even if I measure, right angle. Okay, this is what we call right angle. We all know that. Okay, and it's represented by this little chair or little square over here, or little box over here. But this year you're gonna learn that this right angle is also equal to a number with a degree sign. Okay, this is what we call a degree sign. Okay, you will learn more next week when we talk about angles. But for now, I just need you to know that for right angles, it is actually 90 degrees. So this angle itself is 90 degrees. Okay, this is all I need you to know. Later on, I'll show you more examples with this, and then you see how it is being used. But for now, because I moved a topic earlier, I'll move a topic later. So I need you to just bear with me and just know that right angles are 90 degrees. The number for it is 90 degrees. Okay. Later we'll see how we're gonna use this 90 degrees to solve some of the problems. All right.